been like this, when you've seen polynomials like this, you say, math teacher, how am I supposed to integrate a polynomial when the denominator is in an unbasic, uncommon form? Well, don't worry. Things like this are no longer scary using the amazing technique of partial fractions. Actually, integrating a polynomial like this becomes easy like this real quickly using partial fractions.
Okay, so when we have a polynomial that looks like this, what we want to do is break it up into two fractions that we do know how to solve the basic forms of to get So on the a side, we have 2 minus x in the denominator and 2 plus x in the denominator of the b side, equal to 3 over 4 minus x squared. We're going to multiply through by the denominator of our original fraction, which will give us a times 2 plus x plus b times 2 minus x equals 3. And from here, we can set up a system of equations to solve for a and b. B is by expanding both of the parts that are multiplied by a and b to get 2a plus ax plus 2b minus bx equals 3. Then we can group like terms. So the 2 times the a and b plus b plus the a minus b times x equals 3. Now we can set up a system of equations because we know that in the denominator of our original fraction there's a 3, so the 2a plus b, since the a and b are going to be just numbers, is going to be equal to 3. And since there are 0 x's, the a minus b is going to be equal to 0. So we know that a plus b is equal to 3, and a minus b is equal to 0. So we left off with these two equations. And to get a and b by themselves in the first equation, all we have to do is divide both sides by 2, and that will leave us with a plus b equals 3 halves. And now we have two equations that are easy to add, and that will give us one equation with one variable, because a and b are variables in this case. So if we add these two together, the b's will cancel, and we're left with 2a equals 3 halves. And then we just divide by 2 to get a by itself, which gives us a equals 3/4. Now, since we know a minus b equals 0, 3/4 minus b equals 0, so b must be 3/4. And we solve for a and b. Okay, so now we're just going to use this side of the equation to finish our integral. So we're going to have the integral of 3 over 4 is 2 minus x dx plus the integral of 3 over 4 times 2 plus x dx. And we can take the 3/4 out because if you multiply an integral by something, is the same thing as multiplying on the inside this on the outside. So 3/4 times the integral of 1 over 2 minus x dx plus 3/4 times the integral of 1 over 2 plus x dx. And then we use our basic knowledge of integrals to determine that this is this integral is the natural log of 2 minus x. So what we end up with is 3/4 times the natural log of 2 minus x plus 3/4 times the natural log of 2 plus x plus c. And to accommodate for the fact that there is a minus x in the variable part of the integral down here, we have to put a minus because the derivative of this would be, minus, you'd have to multiply by -1.
The method of partial fractions not only works with that don't have anything on the numerator, as in anything with the power, but also work with things that have a power greater on the numerator than on the denominator. And remember, these partial fractions, it does in fact need to be have a greater power on the numerator than the denominator. First of all, to make this much simpler, we can use long division magic. Actually, just going back to algebra and our basic algebra, we can use long division as shown to have a result that's much simpler to integrate.
The end.
1 is the loneliest number.